Okay, so this is going to be talking about ion-dipole interactions. And so everything we talked about with dipole-dipole before still holds true for that end of the deal. So this is, ionic compounds with polar molecules. So as molecules become more polar, they're going to interact with ions more strongly. So, more polar bonds, stronger polarity of those bonds, all that stuff we talked about before is still in effect. Now we're also going to add to that increasing charge density of ions is going to increase this because the ions are also part of this interaction. So, we have the partial positive and negative region of the polar molecules is going to interact with the full positive or negative regions of ions, or full positive or negative ions. They don't have regions, they just are positive or they are negative. So this is going to be very key for solubility, like we talk about salt dissolving in water. That's ion-dipole interactions. Water is a polar solvent, it's a polar compound. It will dissolve an ionic compound like NaCl, table salt, through these types of interactions. And so the water has areas of partial positive and partial negative. So a group of waters will interact with a single sodium ion or a single chloride ion. And like in the case of the chloride ion, it's negative, so the positive parts of the water are going to interact with it. We'll talk about that more when we get to it. There's going to be a section on that. But in terms of increasing the strength of these interactions, increasing our polarity of our molecules, or charge density of our ions. So that means that either it has a larger charge, be it positive or negative, farther from 0, 1, 2, 3, or minus 1, 2, 3, whichever way. Or it gets smaller. Either one of those works. So if we have, something like this guy right here, this polar molecule from the last video, 3 carbons with a chlorine in the middle, or something similar to it. I guess those actually have longer chains. This will be a little bit, has less non-polar area, so it'll be a better solvent for this. Which of these ions would interact with this most strongly? Well, if we look at our periodic table, we see that these are all elements in the third row. You can see it right over there, I'm sure. They all have filled their valence shell, so phosphorus becomes phosphide -3, sulfur sulfide -2, chlorine chloride -1. But which of those are going to interact most strongly with the polar compound, polar molecule? Well, they're all going to be about the same size because they're in the same area of the periodic table, they're in the same row. And so then we go, well, which of those has the largest charge? And the answer is phosphide. So it has the largest charge. And we'll make a note here, they're all about the same size. So that means that phosphide here would have the largest charge density, it would have the strongest interaction with a polar compound. So that's what we're looking at. So that's how you increase dipole-ion interactions, or ion-dipole interactions. However you write it, whatever. That's how you increase them. So you can increase the strength of the ion, or you can increase the strength of the dipole. That's really what it boils down to. So this one's pretty straightforward because we kind of have talked about it already, but one more to go. So hang in there. We'll talk about hydrogen bonding, which is a little trickier.